Okay, year 12, we're back, of course, with applications of differentiation of, it should be log of x there. Oops. Applications. I know we love these things. Tangents and normals a lot of the time. Okay, so given that we can differentiate it, then we can, find the equation. So we can find the gradient. We can find the equation of a tangent or a normal somewhere. So show that the tangent to this line at this point has this equation. Well, how do we do that? We will differentiate that. I'm going to say y equals, I'm going to say function x because I prefer the function notation. Therefore, function prime x equals 1 over x, and function prime e equals 1 over e. Therefore, y minus 1 equals 1 over e into x minus e. Alright, therefore, keep working down here, y equals x over e minus e over e, minus 1 plus 1, cancel. And I can rewrite that as, so I end up with y equals x over e, because these cancel out, multiply both sides by e, and I get x equals ey as required. Strange way to have x as the subject, but anyway, that's our case. Find the equation of the normal to this at that point there. Well, m1 equals 1 over e, therefore m2 equals negative e. Again, y minus 1 equals negative e into x minus e, for y equals negative ex plus e squared plus 1. That's about it. Right, we can't get that very much neater. Now, we want to sketch the curve, the tangent, and the normal. Find the area of the triangle formed by the y-axis. Well, we know that this passes through the origin. That's helpful. All right, I've got I have a straight line passes through the origin. So those intercepts there, nice, neat. This one here doesn't pass through the origin. I'm going to say let y equal 0. Therefore, negative ex plus e squared plus 1 equals 0. That means that negative ex equals negative e squared minus 1. That means that x equals e, right, because that's e squared over e, and the negatives cancel out, plus 1 over e. Right, so I have an intercept there as well. I have an x-intercept. A y-intercept. Can I squeeze this one in? At y equals 0. No, x equals 0. Therefore, y equals e squared plus 1. Now, let's sketch this out. I'm going to run out of space to do all my calculations, but so we know that we have our exponential looks like this, right? That's y equals log of x. That's y equals log of x at the point E1. That's over here somewhere. That's E. That's 1. Now my tangent there, right, it goes, it's about as good as that line's going to get, I'm afraid. Righto, so I have a tangent to the curve here. You, of course, would use a ruler. Yeah, there is our tangent, right? At that point there, and it goes vaguely through the origin. And then I also have my normal at that point here. It looks something like this, I suppose. And down here. Right, to sketch it, right, we worked out that here on our x-axis, we know that that is e plus 1 over e, and I know that up here we have e squared plus 1. E squared plus 1. And I want the triangle, the y-axis, the tangent, and the normal. So I'm after this triangle here. We see these questions frequently enough that we should know the tricks here. And, oh, look, there's all my space. That's all the space I needed. We know that the area is half the base times the height. Right, and I'm going to say my base is e squared plus 1 equals half, 1 over e, is half times e squared plus 1. And my height here is e is, I'm going to say it's e over 2 outside of e squared plus 1. Righto, there's our area, square units. Rightio? Now I've got another one here. Sketch y equals x log x. There's some bits to do with this. There's a little bit of work to be done. So first of all, my domain. X has to be greater than 0. That's my domain. I can't have anything 0 or below in here, so there's my domain. It's all going to be to the right of the y-axis. That's a good start. What else do we know here? We could say let y equal 0 to find our x-intercept. And I don't think it's going to surprise us very much, but we have x log x equals 0. Now, log x can't be 0. So that means that, oh sorry, x can't be 0, so all we can have is log x equals 0. Right, that's going to have to be my null factor, because this can't be 0. Well, if the log of x is equal to 0, then we take the exponential of both sides, and then e to the log of x. Right, let's write that for a change. E to the log of x equals e to the 0. So that means that x equals 1. So I know that I have an intercept there at x equals 1. What else do I need to know? Well, I can differentiate this. So dn dx of x log x equals, well, I get 1 times the log of x plus x over x is log of x plus 1. Now I'm going to say, let's see if that can be 0. Because that's going to give us our stationary points. d1 dx equals 0. Therefore, log of x plus 1 equals 0. Therefore, the log of x equals negative 1. That means that x equals e to the negative 1. X equals 1 over e. Now, the function of 1 over e equals 1 over e times the log of, I'm going to say e to the negative 1, is that okay? Because that's 1 over e, and that works a bit better, equals, right, because that's negative 1 here now, so I get negative 1 over e. So, I have a stationary point at 1 over e, negative 1 over e. I have an intercept at 1, 0. There is a hint here that as this thing approaches infinity as x gets really close to 0. So x can't be 0, but as it gets close to 0, my function here approaches infinity, does it? Does it? Anyhow, so we've got this thing here. What else do I need to know? Let's have a look at our second derivative, function double prime x. Second derivative, this is our derivative. If I differentiate that again, I get 1 over x. Now, can that equal 0? No, so there are no points of inflection, right? No points of inflection. But let's see what's happening in second derivative at our horizontal point. So at our stationary point there, function double prime of, not of x, but of 1 over e equals 1 over 1 over e equals e, which is positive. So things that I know. Here's my sketch. I know that it is a steady up. I know, in fact, I've kind of got to infer, and there's a little bit of magic that goes on there. I'll have to explain that in class. But here at 1 over e, 1 over e, right, I've got this horizontal, this stationary point here, and over here, because 1 over e is, you know, a little bit less than a half, and here at 1, I've got my intercept. So what happens is, it comes down here. Oh, that's got to be my minimum there. I didn't draw that terribly well. That's really got to be my minimum there, but it does get very steep there. Rightio. And that's my sketch. That's it. There's always a bit of work in those. What does it say? 3a, review of logarithmic functions. That's not what's going on. That's the end of this video. Let me review the notes and I'll see you in class.